So we know that the factors of a polynomial function are useful because they tell us the zeros of the polynomial, which is the same thing as the x-intercepts. And we know that synthetic division can help us identify the zeros of a function because when we put a number in and get a 0 for the remainder, the number we put in is a 0, which then tells us that x minus that number is a factor. But which numbers should we try? Suppose I'm trying to find the factors here, or the zeros of this polynomial. The synthetic division is going to be a trial and error process. I need some guidance as to what numbers I should try. Now, there is a rule that will give us what we call the possible rational roots of a function, meaning it's a list of any number that could possibly work as a 0. And that rule is that if a number is going to work as a 0 for this function, and actually we're just talking about rational numbers, we'll ignore square roots and stuff like that for now, then that number is going to be of the form a factor of the constant term divided by a factor of the leading coefficient. So here's how you figure out the list of numbers you want to try in synthetic division when you're factoring a polynomial. Our leading coefficient here is 1. And our constant term is 25. Well, 25 has factors 1, 5, and 25, and 1 has no factors. So look at all the possible combinations we can make here. 1 over 1, that's 1. 5 over 1 is 5, and 25 over 1 is 25. So if any numbers are going to work as a 0 in this function or as a factor of this polynomial, it's going to be one of the numbers in this list, positive or negative. So if we're going to do some trial and error with synthetic division, the only numbers we need to try are these 6, 1, -1, 5, -5, 25, and -25. Okay, so that limits the numbers we have to try, which limits the number of errors we're going to make, or the number of ones we're going to try that don't work. Let's try that here. Our constant term is -35, and that has factors 1, 5, 7, and 35. And our leading coefficient is 33, which has factors 1, 3, 11, and 33. So that gives us, don't forget positives and negatives, 1 over 1, 5 over 1, 7 over 1, 35 over 1, 1 over 3, 5 over 3, 7 over 3, 35 over 3, 1 over 11, 5 over 11, 7 over 11, 35 over 11, and 1 over 33, 5 over 33, 7 over 33, and 35 over 33. Awesome, right? That's super. You are going to run into something like that in my math lab, but the good news is it's going to be a multiple choice. So you just need to look at these numbers, remember plus and minus, factors of the constant on the top, and leading coefficient on the bottom. Don't flip that. That's the most common mistake, and they always include that as a wrong answer too. All right, one more. This is much more like I would put on a test. An easy one to illustrate, show you how nasty my math lab's going to be. If I were writing the test today, this is what I would put on it. My factors of 5 are 1 and 5. Factors of 12 are 1, 2, 3, 4, 6, and 12. So the possible rational roots are 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 6, and 1 over 12. And also 5 over 1, 5 over 2, 5 over 4, 5 over 6, and 5 over 12. Nowhere near as ugly as that list. Actually, I take it back. I wouldn't even put one with this many on it. But that's how possible rational roots work. Okay? Plus or minus all the factors of the constant over all the factors of the leading coefficient, and then write down all the possible combinations there. Okay? That's it.